Well, it's my great privilege to introduce to you Professor Peter Harrison. He is an Australian Laureate Fellow and Director of the Institute for Advanced Studies in the Humanities at the University of Queensland. Prior to taking up his present post at UQ, he was the Idrios Professor of Science and Religion and Director of the Ian Ramsay Centre at the University of Oxford. He's the author of over 100 articles and chapters. His 6 books include The Bible, Protestantism and the Rise of Natural Science, 1998, and most recently, The Territories of Science and Religion, Chicago, 2015. And that latter book is based on his 2011 prestigious Gifford Lectures. Peter, we are so looking forward to your talk entitled Christian Origins of Modern Science. Thank you, Peter.
Thanks, Jim, for that welcome, and thanks to the Sydney College of Divinity for its hospitality. I'm also grateful to Doro for his invitation to speak here. I'll say something briefly about my involvement in this project. This is something I've been deeply interested in, because in typical science and religion dialogue, the orthodox tradition has been conspicuously absent, and my involvement on the scientific committee is not, as you'll discover this evening, a function of my intimate knowledge of the significance of the Eastern Orthodox tradition in relation to scientific developments, but rather as a very interested observer and someone who's learned a vast amount since I've been involved in this, and presumably I will continue to do so this evening. My talk is about Christian origins of Western science, of modern science, and as you'll see, it's very much focused on the Western tradition, but I will offer some comparative observations, partly in relation to what is distinctive about the Western Christian tradition, and how those distinctive features of the Western Christian tradition are a partial explanation of why science arose when it did and where it did, that is to say, in the 17th century and in Western Europe. So I'm going to talk essentially, as you can see, about 4 things. I'm going to talk about how religion played into the issue of motivation, how religion gave social legitimation to scientific practice, how religion provided presuppositions without which science would not have been possible, and then how religion also contributed to, or Christian religion in particular, the specific methods of inquiry that are distinctive of modern science as it begins in the West. So to start with motivations, and I'm going to say very little about this, except that virtually, although we often hear in public discourse the idea that there has been a perennial battle between science and religion in the West, and that science evolved in the West essentially in opposition to religion, exactly the opposite is the case. That without religion, science never would have got off the ground. And that's partly the thrust of much of my research and publication. So I'm just going to really, the tip of the iceberg this evening with these 4 aspects of how religion has played this positive role and a necessary role without which I would argue science never would have taken place. So what are the motivations of the specific individuals who are involved in the emergence of modern science? And if we think here of key figures like Galileo, Isaac Newton, René Descartes, Robert Boyle, Kepler, all of these figures were committed religious believers. There is no doubt about that. And this is even the case with Galileo, who remained a committed Catholic to the end, in spite of clearly this opposition he received from some elements of the Catholic Church. Galileo was actually a member of the secular clergy to the day he died. So motivations, as I say, I won't say much, but I'm just going to give you 2 examples of the way in which key figures were motivated by their religious beliefs and said so. And we have here Johannes Kepler, and Kepler, I think, is actually a more important figure for the development of modern science than was Galileo. But And the reason for this is, as we'll see, he developed the key 3 planetary laws that Newton was subsequently to convert into the single universal law of gravitation. But you can see here what Kepler has to say about what motivated him to his astronomical inquiry. He sees astronomy as essentially an intrinsically theological activity, and that's why he is motivated to do it. His original vocation was with the church, but he now sees that studying astronomy is as religious a vocation as was his original vocation with the church. There's a kind of interesting Lutheran twist to this here, which I won't go into in much detail, but there's a Lutheran notion about vocation that's actually underpinning this conception. And one other example, Robert Boyle, a key figure in the development of modern chemistry. Some would say the father of chemistry, and you may have come across Boyle's law in your physics class at high school. P1 V1 equals P2 V2. Ringing any bells? Maybe not. But anyway, here is Boyle on how he understands his scientific activities. So, discovering unto others the perfections of God in the creatures, that's what he sees science as being about, is a more important religious act than these particular rituals of sacrifice. Rational contemplation of nature is philosophical worship of God, or reasonable worship of God. This is actually a quote from the New Testament. So one of the right ways to worship God is through scientific practice. So they're just 2 examples, but we could multiply this not to infinity, but we could multiply it a lot. That key figures see the pursuit of science as an intrinsically religious activity, and that's why they're engaged in it. And this one is fairly conceptually simple, so I'm not going to spend a lot of time on it. I'm going to move on to one. This one is much harder to get, social legitimation. And this one is hard to get because we think of science as something that is self-evidently a useful and important activity. And that's why it's a kind of a central cultural feature of modern Western society. It's something we value. It has become the gold standard of our knowledge, and we think it is something that is self-evidently important to pursue. That was not the case in the 17th century when science begins. Science needs to establish its credentials. It has to make the case that it's worth getting behind. And to give you some indication of this, for those of you who know your English literature, Jonathan Swift famously, in the early 18th century, mocks the Royal Society for its activities and regards them as completely useless. And this was not an uncommon view. So while we think of the Royal Society as one of the most elevated and important bodies in the Anglophone world, in the 17th century, they were mocked relentlessly by many detractors. Science, in other words, had low status. So how do we get from a situation where science has low status to where we are today, where science is regarded as, in a sense, the gold standard for knowledge? Religious legitimation is a key part of that story. It's not the whole story, but it's a key part of that story. So just hold that thought, and I want us to think about something else. Why is it that science emerges only in Western Europe in the 17th century? What are the key cultural variables that make science happen then? And crucially, here's the crucial part, it's not just that we have brilliant scientific minds, but science is consolidated. That is to say, it builds its momentum, it becomes a central feature of the culture. And that is the unique thing about science in the West. Why? Because we encounter science in other places. But the story of science in other places is the story of a boom-bust pattern. Science does not consolidate anywhere else except in the West. So when we're trying to explain the phenomenon of the status of science in the West, what we have to explain is not merely brilliant people coming up with scientific ideas, but why culture gets behind it and backs it and why it consolidates. And the classic contrast cases are ancient Greece, where we have science, but it doesn't consolidate. Medieval Islam, where we have science, but it doesn't consolidate. and China, where we have science and technology, but they don't consolidate it there either. And the reason that science is not consolidated in these contexts, and indeed I would suggest the same is true for the Greek East, is that there are other things that are valued and that have a value that either are equivalent or greater than how science is understood. Okay, so why do we value science? How does it get to be consolidated in the West? Religion is a key part of the story. Okay, and again, the shorthand version of how this, it's a long, complicated story, but just to give you some ideas, the key thing is values. We have to have a set of values that give rise to the notion that science is something that ought to be pursued. And the first person in the history of scholarship to cotton on to this is the sociologist Robert Merton. Merton's a very interesting figure. He gave us terms like self-fulfilling prophecy and unintended consequences. So he's a key figure in the sociology field, but his early work, his PhD work, was actually done on the sociology of science. And he was very interested in the question that, in a sense, I put before you. Why does science take off when it does? And crucially, why is England, in particular, a centre of scientific activity in the 17th century, culminating in the work of Newton, for example? Why England? Why the 17th century? And he looked at the composition in this book here, Science, Technology and Society in 17th Century England, and gave a sociological analysis of the makeup of the Royal Society. And this was his analysis, that if you look at the makeup of the Royal Society, what you find is that Puritans are disproportionately represented in the membership of the Royal Society. Now, since Merton, there have been challenges to this notion of Puritan origins of modern science, and there is certainly something to these challenges. So I wouldn't want to go all the way with this notion that was developed in the 1930s and 40s, not only by Merton incidentally, but by Dorothy Stimson. I wouldn't want to go all the way with that, but what I would say is the question that Merton is asking is exactly the right question. What are the values that underpin science? And they're not scientific values per se, they're moral values or they're religious values. And he thought that the values of Puritanism were the kinds of values that made possible for science to get up and running and to be consolidated. What specifically are those values? I wish I had the time to spell them all out, but I think a key part of the values are to do with a particular Augustinian understanding, going back to the Church Father Augustine, 5th century, about the human condition as a fallen condition and the need to restore not merely the fallen condition of human beings, but the fallen condition of the world. So a strong view of original sin, in other words, combined with an activist understanding of how we must overcome what original sin has done to both us and to the world. And just to give you a specific example, Francis Bacon is really, I think, a key person. Francis Bacon, Lord Chancellor in England, 17th century, doesn't do scientific work per se, but sets out sets of arguments about why we ought to back science and why the Kingdom of England ought to put its money behind science. And here's what he has to say, and this will give us, that's him there, nice collar, but here's what he has to say about how science ought to be legitimated, where it derives its religious legitimation from. So, man by the fall fell from his state of innocency and his dominion over the creation. So there are two aspects to the fall. One that's moral and one that's a loss of our control of nature. And he goes on to say, both of these losses we can fix up in the present life, one through religion. So our moral deficiencies can be addressed through religion. But the loss of our control over nature can only be addressed if we invest in science. That's what the purpose of science is, the redemption of nature, the restoration of the control that we used to have over the natural world in our original state of perfection in the garden. So the classic story of Adam and Eve in the garden. Adam named the animals. Basically, the animals did what they were told. After the fall, Adam is expelled from the garden. the creatures rebel and become wild. We get wild weeds and all kinds of things. So the aim of the redemptive exercise is to re-establish control over nature. How do we do that? We do it through science. So science becomes... So the whole purpose, the whole justification for the pursuit of science is for Bacon tied up in this notion of a fall from original perfection and an attempt in part to regain that. Okay? So it's slightly different. Religion fixes up the moral, science fixes up the physical, as it were. Now let me give you one other example from Bacon, and this is where I think we see a big difference between the Western tradition and the Eastern tradition. So here is Bacon again. And Nikos said at the outset about science, science is not the term they're using at this period in history. They're talking about philosophy and natural philosophy, and that makes a key difference. Our idea of science doesn't kick off until the 19th century. There are no scientists until the 19th century. That's when the English word is invented. Right? These guys regard themselves as philosophers. They're doing philosophy. And here is Bacon on the point of pursuing philosophy. It's not to be sought for resolution, and I'll come back to what that means, but to a reinvesting to the sovereignty and power which he had in the first state of creation. So it's the point he made before in the previous slide, but I'll just expound that a little bit more. But let's look at the second one as well. The true ends of knowledge, and he's saying the same kind of thing, and not for the pleasure of mind, but for the benefit and use of life. And then a reference to charity. This is a significant change in understandings of the purpose of philosophy and the idea of charity. The purpose of philosophy classically was to do with the perfection of the intellect. In the Aristotelian conception, the goal of life is the perfection of what human beings, what their unique features are, and that is rationality, reason, intellect. To some extent, I think, we see this when it comes into the Christian tradition, and the aim of the Christian life is theosis, to become, through various contemplative exercises, to become reunited with God. The Protestant reformers are dead against this conception, although, okay, that's an overstatement, because some people have argued that Luther does have a conception of theosis. But here, a key Reformation idea theologically is that we do not become perfect, but rather, in spite of our imperfections, we are justified before God. Okay? So that the aim of the Christian life is not to become perfect. The aim of the Christian life is, in a sense, to reside in the perfection of Christ, whose perfection does the job for us. So we are reckoned or regarded as good without actually becoming good. Okay, now this is a vast overstatement of a key difference between East and West. Right, it's a very crude black and white version, but it will do for the purpose of the exercise, because what is being said here is, and this is what Bacon is wanting to argue, that the whole philosophical conception of perfecting the individual is a mistake. We should forget that and seek to re-establish dominion, not over ourselves through the perfection of our intellectual life, but to re-establish a dominion over nature. And science becomes the means by which we do that. And I would argue that's a very distinctive understanding of the West, and it arises out of a distinctive, it begins in Catholicism, and it's quite specific, particularly in Calvinist understandings of justification. And that's what we see in Bacon himself, although there's much more that could be said to qualify that, right? So we're dealing in big picture stuff here, but that's basically what I want to argue. Now, if we go on to what's the empirical evidence that might suggest that there's something to this, if we look at where we can locate scientific activity in the 17th century, in this key period, right? Was this up? Has this always been up here? Okay, right, let me click again. A lot of it's going on in England, right? And this is a very crude measure, okay? It's a very crude measure, but it's very interesting. How do we account for this? And how do we account for the fact that Spain is not even there, right? So France is at least largely Catholic, although there's a Huguenot population. Italy's going to be Catholic. Germany is going to be mixed. The Dutch are going to be Reformed, more or less, as the Danish, the Flemish, Polish Catholic, Swedish Reformed. And of course, Eastern Europe is not represented at all. But the key thing is, where is Spain? It's a hugely important civilization at this period of time. It's totally Catholic and it's completely missing from the equation. Okay. Now, as I've said, the stats are fairly crude, but I'm dealing in big picture stuff here. So what all of this suggests is that there is something rather distinctive about the Christian tradition as we see it in an exaggerated form in Protestantism. I'm not saying that Protestants are the only ones who are doing science, but I do think that Protestantism plays a huge role in legitimating scientific activity. So Descartes is Catholic, Galileo is Catholic. They're hugely important, but the consolidation of their work doesn't take place in Italy, and it doesn't take place in France. Interestingly, it takes place in England. Okay, so that's the kind of point I'm wanting to make. You don't have to be a Protestant to be a good scientist, but Protestantism gives rise to sets of values that really will help consolidate scientific activity. And my colleague Stephen, who teaches at an institution just down the road, University of Sydney, in this really important book about the emergence of the scientific culture, here he is, he's talking about legitimation and consolidation, which are really the two key things that I would stress are important about the rise of modern science. It's not just having smart people doing science, it's consolidating it and giving it social legitimation, not from a separation of religion and science, but from their coming together. Science and religion were more separate in the Middle Ages than they were in the 17th century, and their coming together in the 17th century is a key part of why science takes off in the West. Okay, so that's the legitimation story is the hard one to get, I think, because we don't naturally tend to think in these terms. We don't think in these terms because science has so much status at present. Okay, but it didn't in the 17th century. Right, let me move on just to the last two things that I want to talk about. Presuppositions. In order to do modern science, we need a quite distinctive set of presuppositions, and the one I'm going to talk about as key is laws of nature. I'll come back to Kepler. Kepler comes up with these incredible laws of nature that are mathematical in their form. The first one is that planets move in ellipses around the sun with the sun at one focus. The second law is that, you can see the second law there is actually the purple, that planets carve out an equal area under the curve in equal times. Okay, so those areas A1 and A2 are equal. And the third one is really quite remarkable, that the square of the period of the orbit, the time it takes to move around the sun, is directly proportional to the cube of its axis, the distance between the planet and the sun. So the square of the... Why? Why is that the case? Why does maths turn out to be predictive of what's going on out there in the world? Eugene Wigner famously talked about the unreasonable effectiveness of mathematics. Well, Kepler's answer is it's a theological one. That God instantiates or puts in place mathematical relations. And were it not for that, says Kepler, the world would not be mathematical. We would not understand the world in terms of mathematical laws. And all the references to Aristotle there, and this is that's the third law, T squared equals A squared, the square of the period, the cube of the, it's actually the half of it's the semi-major axis, but we can talk about that later if you're interested in maths, but you're probably not. Aristotle doesn't think maths apply to the natural world. Kepler thinks they are, and he thinks that for theological reasons because he has a doctrine of creation and an idea of God as a mathematician. That's a key presupposition for modern science. It doesn't happen before the 17th century. No one thinks about laws of nature in that way before then. And just to give you an example, Descartes, René Descartes, the famous French philosopher, is the author of the notion of laws of nature. And what are laws of nature for Descartes? They're not regularities that just happen to be inherent in nature. They're laws that God directly imposes on nature. So when we're studying laws, they are laws literally that God has instantiated or promulgated. That's what Descartes means by law of nature. And this is the first time we get an understanding of laws of nature in that sense. And then the English guys pick this up. They don't agree with Descartes about much, but they agree that God is the author of the laws of nature. Here's Robert Boyle. Laws of motion are not a function of matter. They're not intrinsic to matter. They're imposed on matter by God. Samuel Clarke, you may not know him, but he's probably the most important theological philosopher of the 17th, 18th centuries. And he is a Newtonian. He's the guy who argues with Leibniz. Now, there's a famous correspondence between Leibniz and Clarke. But again, the course of nature is nothing else but the arbitrary will and pleasure of God acting on nature. That's what laws of nature are. Only in the 19th century do people think about laws of nature as being intrinsic to nature. Do they think of laws of nature as not having reference to God at all? And it follows from this thing, as Newton will say, and this is a key thing. Notice he's talking about philosophy still, but let's substitute science for that. To discover the laws that God chose, not the ones that he might have. So God could have chosen any number of laws. Why is it that the square of the period is proportional to the cube of the axis? Why is that? Why isn't it the square and the square? God could have done it anyway, says Newton. In order to find out, we have to do experiments. Right? We have to do empirical investigations. So the justification for empirical investigations that discovers the inherent laws of nature is a function of this theological conception of God as instantiating or imposing laws of nature on the material world. And that leads us kind of neatly into methods of inquiry. So the Aristotelian science that this new science replaces, Aristotle is not an armchair scientist. He believes in observation, but he believes in common sense observations. Light stuff falls slowly and heavy things fall quickly. That's what we observe. Why would we think things are otherwise? So you've kind of got to think counterfactually to get science up and running. Think how God might have done things in a theoretical way. Why would we not be able to intuit directly from basic observations, as Aristotle says, rather than lots and lots of observations conducted under tight experimental conditions? And that brings me to this point here, and it gets back to part of a strongly Protestant view of the fallenness of human beings. Calvin and Luther, just look at the Luther quote, because that really sums it up. We can't know nature because after the fall of Adam, our reason doesn't work anymore. Okay? And the point about Calvin, this is his so-called total depravity, that after the fall, it wasn't just a moral aspect, our intellect and our senses were damaged as well. Given that, what do we need for knowledge of nature? Well, it follows that we're not going to have very good knowledge of nature, we're going to have probabilistic knowledge of nature, we're going to have to do lots and lots and lots and lots of experiments, we're going to have to use instruments to help our weak senses, we're going to have to a community working on it, and it's going to have to be a long-term project. All of this is very new, and I'm cutting a long story short here, but I'm getting close to my 20 minutes, so I've got to stop. Here's Robert Hooke, who is the first curator of experiments for the Royal Society, a key figure, the guy who came up with the inverse square law at the same time as Newton. Some people think before Newton, but anyway. Every man has an innate corruption, right? Original sin. What follows? These are the dangers of human reason. Our reason is unreliable. The remedies can only proceed from this new experimental approach. That's what we need. So original sin, ironically, paradoxically, surprisingly, figures crucially in the origins of experimental science. And here we have, what are the key features of experimental science? It's probabilistic. Aristotle said we can demonstrate rationally how nature is. The experimentalists say, no, you can't. We only see appearances, we don't see the essences of things. It's corporate. We need lots of people. We need something like a royal society. You think about the huge numbers of people who are engaged in scientific activity now. That's the legacy of this view. And it's cumulative. It takes a lot of time. Experimental rather than speculative. All I mean by that is that knowledge is based in experience not reason, because we can't trust our reason. Our senses are full, and that's why we need telescopes and microscopes. And we need to investigate nature aggressively, because nature itself has fallen and is no longer transparent to us. It's opaque. It's difficult to understand. So wrapping it up, experimental method then is like a therapy. It's a therapeutical regimen that we need to overcome the limitations of reason and the senses. Okay, so it's time to wrap up. And wrapping it up. So historically, science, Christianity and science have interacted in a number of different ways. The picture is complex, and I've given you a very simple black and white version that really needs to be nuanced in lots of ways, but I've only got 20 minutes. So 16th and 17th centuries, religious factors played a positive role, not merely in the emergence of science, think here motivations, but its consolidation and persistence. Think here about the legitimation question. Legitimation, okay. We also need a new set of presuppositions and laws of nature, which is a new idea, provides that, and it's theological in its origins. And then how does an idea like the fall, quite specific Christian notion, work? It actually feeds into notions of experimentation. And that, folks, is where I'll leave it. Thank you.
Thank you, Peter, for a scintillating talk. That was deeply informative for us who do not understand the developments of science, but I think we all do a bit better now.